Welcome back to our discussions and thank you for always joining us. We are presenting K.c.s.e 2005 paper 2 number 23. And the question we have read, the diagram below represents a cuboid A, B, C, D, E, F, G, H, in which FG is 4.5, GH is 8 centimeters, and HC is 6 centimeters. First part of the question, calculate the length of FC. The first thing we are going to do is to calculate or to connect A and F, and again do the same from F going to H, such that if we drop a line from C towards H, we are going to have a right angle at this particular point. But remember, we cannot be able to calculate FC if we do not have FH, and therefore we are going to use this triangle FHG to get the length FH first. So if we are going to use this triangle at the lower part here, the triangle is going to look like this. This one is going to be our F, this one is going to be G, and this one is going to be H. Remember, FG is 4.5 centimeters and the GH is 8 centimeters. And for us to find FH, we are going to use Pythagoras theorem by getting the square root of the squares of the sum of the squares of FG, which is 4.5 squared, plus GH, which is 8 squared. And this one is going to give us the square root of the sum of these two will give us 84.25, which is going to give us 9.18, which is approximately 9.2 centimeters. Once we have gotten this, we can now go down and get the length of FC. Again, we draw another triangle with F here. This triangle is running all the way to H, then going up to C, then coming to F again. Remember, we have CH as 8 centimeters. We also have FH as a FH is 9.2 centimeters. That means again for us to find FC, we are going to use Pythagoras theorem, where we are going to get the square root of 9.2 squared plus 8 squared, and this one is going to give us 120. This one is going no, this is a mistake. We have C coming back to H as 6 centimeters. So this one is 6 centimeters here. So we are going to have 6 squared. And if you take 9.2 squared plus 6 squared, this one will give us the square root of 120.64, and the square root of 120.64 will give us 10.98. This one will give us 10.98 centimeters as the answer to part A of the question. Once we have done part A, we can now proceed to part B. Part B, they need the size of the angle between the lines FC, the lines FC, and also FH, that is the angle between the two lines, and therefore we are going to use the above triangle the way it is to get that particular angle that we are looking for. Remember, this is our F here. Then we have H at this point. We have H at this point, and also C on the upper part. We have 9.2 as FH here, centimeters. We also have CH as 6 centimeters. So the angle theta is going to be found using the tangent, that is where tan theta is going to be opposite, which is 6 divided by 9.2. And for us to get theta, we are going to find tan inverse. We are going to find the tan inverse of 9 over that is tan inverse of 6 divided by 9.2, and this one is going to translate to an answer equivalent to 33.11 degrees as the answer to this particular question. Once we have gotten B, we go to C. In parts, that is B Roman 2, sorry, we go to B Roman 2. That means what we have done is B Roman 1. B Roman 2, we are supposed to get the size of the angle between the line AB and FH. AB and FH. A is here, B is here, and also FH. So we know that AB is the same as FG, and therefore we need to find the angle between FG and also FH. That is FG and FH. So we are going to actually get the angle between the two lines by extracting a triangle that is looking like this. We have the common point F here. This one is going to be G. So this is going to be our 90 degrees. And of course, this one is going to be H. So the angle we need is the angle theta at this point. Remember, we know that GH is 8 centimeters. FG is 4.5 centimeters. Again, if we have to use SOHCAHTOA, we are going to use tan because we have the opposite and adjacent, where tan theta is going to be equal to the opposite, which is 8 divided by 4.5, and this one is going to give us 1.7778, and for us to get angle theta, we are going to find the tan inverse of 1.7778, which is going to be approximately 60.64 degrees as the answer to this particular question. Once we have done that, we can now proceed to part C and complete answering this question. Part C says the size of the angle between the plane ABHE. I can clear this so that we can get what we are looking for clearly. We need the size of the angle between the plane ABH E and the plane FGHE. So what we are going to do, since AB is equal to FG, I'm going to draw the line from A to meet E at this particular point, and also from F towards E, such that the angle we need will be at this point E. We call it angle theta. We are going to draw a line from A to F, such that AF is 90 degrees. We know FE is the same as GH, and therefore this is 8 centimeters. AF is going to be equal to 6 centimeters. Using Pythagoras theorem, AE is going to be 10 centimeters. However, since we have the two sides, we can use them to get the angle we are looking for. We have the opposite and the hypotenuse, meaning the tan theta of an angle is going to be opposite, and the opposite side is 6 divided by the adjacent, which is 8, and this one is going to be equal to 6 over 8 will give us 0.75. That means theta is going to be equal to tan inverse of 0.75, which is going to translate to shift tan inverse of the answer, which is going to be 36.87 degrees, and that becomes the answer of this question. You can also find this angle by using, because FH is going to be 10, because A is going to be 10, you can also use cosine rule to try and get the value of angle theta. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.